Hello everyone, my name is Victor Davila and I'm with Shape Design Technologies. And today we're going to demonstrate a very powerful feature inside of ESPRIT. I have this part over here with this pocket with a corner radius down on the floor. It has a 62 thousandths radius, 62 and a half. And the obstacle that I have here is that I would have to stick out the tool quite far in order for me to clear this ledge. And so what I'm going to demonstrate is you don't need to stick that tool all the way down to clear it. You can use ESPRIT's Collision Avoidance to avoid the tool holder from crashing onto the part. So let's demonstrate first here without the Collision Avoidance. And I have this freeform feature here with the pocket as my part features. And I'm going to grab a 3D contouring cycle, and I have this chain over here as my drive profile of the tool. So I'm going to click OK, and it gives me some toolpath. So let's watch this simulate, and I already know the outcome of this. We're going to see a collision, and immediately we see a collision. As you can see, the tool doesn't have enough stick out in order for it to clear this ledge. So let's go ahead and change our operation over here. And we're going to go to the Collision Detection tab. And you have different levels of it. You have check and report collisions, avoid collisions by trimming. It'll trim the toolpath to avoid that collision. And then avoid collisions by tilting. Now I know that the tool, it's sticking out. If I trim it, it's just not going to give me any tool path because it'll hit no matter where it is on this pocket. So here we have some parameters. We have some tool clearances. We have collision tolerance. Maximum tilt angle is how much do I want that machine to tilt, the max tilt. So I'm going to put 45 degrees. And then I have this enable smoothing. If I put it to none, the tool actually tilts as soon as it finds a collision. Distance kind of, it anticipates the tool, the collision, and you give it a distance of when to tilt the tool before it collides. And then I use the whole path, which it basically spreads the tilt around the whole tool path. In this situation, it's going to have to tilt through the whole tool path because of this height also. You have a rapid links here, and then you have this other rotary axis position on rapid links, prefer side or shortest movement. I'm going to leave it to prefer side. I'm going to click OK. ESPRIT's going to recalculate the tool path. As you see, the tool path moved a little bit because it tilted that tool. So let's watch this now. I'm going to bring the transparency down some so we can see that holder being avoided. So I'm going to come in, and you can see already the B axis is, the B and the C is tilting. Let me speed this up just a hair. It's going to come in there, and let me have this to play. And now you can see the tool holder avoiding the part all the way around. And it gets close, but no collision. And the really nice thing is ESPRIT is taking into account different things in this tool assembly. It's taken into account the shank and the tool holder. And I downloaded this from the Sandvik website. It's one of those hydraulic holders, and so I don't want to damage that holder, and I don't want to damage this machine. This is the machine we have here in our tech center that we offer training, on-machine training with ESPRIT 5-axis. Thank you very much. Have a great day.